Hey everyone! In this mini-series we're going to build a few surprisingly fun and useful circuits using no microcontrollers, just good old transistors. Yep, those tiny three-legged things that quietly run the entire electronic world. Let's just add some resistors, LEDs and a bit of curiosity and check how far we can go with all that stuff. We'll see not only how they work, but also where these simple circuits can actually be used in real life. Today we will start with something unexpected: logic circuits. That's the foundation of all digital electronics. And despite how the word digital sounds, these circuits are actually simpler than most analog ones. You don't need precision components or perfect tuning. Most of the time they'll work just fine across a wide range of supply voltages. And sometimes using just a couple of transistors can be cheaper, faster and even more reliable than throwing in a whole microcontroller to do the same job. Let's start from the very basics. Let's grab one LED, one resistor and one button. When we press the button, it shines a light. Release and it becomes dark. It's either on or off. Congratulations! You've just built your first logic gate. Now let's make it to do something more interesting. What if we could make the LED turn off while supply voltage and turn on when there is no current? Sounds like a magic, but that's how logic inverter or NOT gate works. Let's take a look in emulator. Pay attention to this resistor. Current that flows through it must choose one of two ways. When the input voltage is low, the first transistor is closed. Current has only one way to go, through the second transistor, and that opens this transistor and turns on the LED. But when we apply voltage to the input, the first transistor opens, current flows through it instead, and the second one switches off. LED goes dark. Input high, output low. Input low, output high. Everything upside down. That's the inverter. So where could you use this in real life? Here is a neat example, an emergency light. This circuit is powered by a lithium battery and constantly checks for mains voltage. When the mains go out, the lamp turns on. When the power comes back, it turns off and starts charging. Cheap, simple, reliable, and all built from transistors. Next up, a transistor latch or trigger. This circuit can remember its states even after the button is released. At power on, the LED is off. Press the button, the LED turns on and stays on. That's because the two transistors form some sort of circle. This is called a feedback loop. Each one keeps the other turned on. Let's build it and see. Oops. That's reality reminding us that everyone lies, especially simulators. So what happened? Well, when the latch flips, the base emitter junction of the top transistor and the lower transistor together make a temporary short circuit. To fix this, we'll add a small resistor between the base of the upper transistor and the collector of the lower one. Now it works beautifully. A quick tip: always limit the current of your bench power supply during testing. It can save your day and your components. Now let's make this latch a bit smarter. We can add another button that resets it. That simply shorts the base emitter of the lower transistor and turns everything off again. So now we have one button for on, another for off. Let's try it with something more powerful, say a solid-state relay from my previous video. Check it if you haven't seen it yet, link in description. The relay input connects to the collector of the upper transistor and ground. That's it. Now our little transistor latch can control mains lighting. During my tests, sometimes the circuit randomly switched itself on. I suggest that some electromagnetic interference caused it. Adding a 0.1 microfarad capacitor from the base of the lower transistor to ground fixed that completely. Now it's working perfectly stable. You can easily turn this into a sensor-based alarm, manual reset timer, or event monitor. Write your ideas in comments if you have any. By the way, since we're already talking about alarms and security systems, here's another fun modification. We can make the circuit react not when the contact closes, but when it breaks. Just connect a thin wire or any fragile link between these 2 points. If that wire snaps or someone cuts it, the circuit will trigger, lighting up the LED or turn on alarm. You can even use it as a wire continuity tester. Even a very short disconnection will be instantly indicated. And if you add a simple mains voltage monitor to it, the same circuit can show whether the power has gone out while you were away. So that one little transistor latch doing the job of an alarm, a tester, and a power outage memory all at once. And the best part, it costs less than a cup of coffee, way less than Arduino. And finally, a latch that works with a single button. Press it once and it turns on. Press again, off. Green LED is for on state, red for off. This circuit used 2 transistors again and similarly connected on kinda circle, but slightly different, with negative feedback. When one turns on, it forces the other to turn off. That's why it can stay in either of 2 stable states. To this day, I am still not entirely sure how it works, but it does, and beautiful. The trick here is in the capacitor. Nobody knows why it's here, but without it nothing works. You can run it from 3 volts up to 12 volts, and works with almost any electrolytic capacitor, between 1 and 10 microfarads. As I mentioned at the beginning, digital circuits forgive you a lot of cruelty. Original resistance of some resistors were 4.7 kilo ohms. I replaced all resistors within just 1 kilo ohm, just to simplify things, and it still works just fine. Let's drive my solid-state relay again. So, did you like these transistor circuits? Got your own ideas on where to use them? Share them in the comments. I'd love to hear what you come up with. And remember, this is just the beginning. In the next episodes, we'll dive deeper into analog circuits and some wild transistor experiments. Subscribe if you haven't already, and may your ideas turn into real circuits.